Let's see what happens. What I need to do, so we have 0 viewers right now. So this is the broadcast, and whoever's watching this, you might need to start. So you're watching this now at the start of the video, and I'm looking at the screen. Like, you can see me seeing me over there. So because you can see me seeing me seeing me. All right, so we're getting this going right now. We have 0 viewers because I'm probably gonna need some people to help. This is something new I'm pioneering right now. New control room. So at this point, if you're watching this broadcast, you might want to like fast forward to see when I'm actually doing some statistics. We're gonna see people log in to see what's happening. I might need to call the stats department to tell them I have a room downstairs. We have 0 viewers right now. Now I'm hearing you. Am I watching the broadcast? Okay, so we're having a lot of interesting things happening right now. We're still 0 viewers. Okay, here's the review session. Hey, Ashlyn. And, oops, I'm typing into the chat thing. Let's see if I can, this is gonna be interesting. Okay, now I'm live. Do you hear and see me live? I think there might be a bit of a delay. Let's see how long the time delay is by holding up my hand. Let's test this. 1,000, 2, 1,000, 3, 1,000, 4, 1,000, 5, 1,000, 6, 1,000, 7, 1,000, even, okay, there's a long delay. There is a delay on this. I guess YouTube wants to make sure I'm not doing anything crazy. I'm about to hold up my hand for one, so that in the future. So we have 2 people watching this. Let's see. What I want to try to do here is I want to try to switch between. Just wait until I hold up my hand. I'm so sorry. This is literally technical training right now. What did I just say? I'm holding my hand over the webcam. Okay, we have 10 viewers. So we're going to try to share the screen. Okay, screen share. Okay. I'm almost got this figured out, everybody. Okay, I think I know what to do now. Learning curves are so fun. I'm going to open up the practice test, everyone, and I think I can get it to share the practice test. We've already lost like 1 or 2 people. They're like, this guy has no idea what he's doing. If you have any questions in general, you can ask them right now. I'll be looking at the chat in a half moment there. I think what I'm going to do is I need to take the chat and bring it over to my screen over here. Okay. Okay, so I've got the chat over here now. Okay. Give me a half second, everybody. I'm about to pull open the practice test. Okay, let's try this. If I can screen share the practice test, will be good. So I need to scroll down on that. Okay. So let's start. What question would people... What question do you guys want to talk about on the practice test? It's probably going to be quicker if I type to you guys if I have to communicate. So use the chat to communicate, because now I'm seeing the screen share happening. Okay, I'm pulling up question number 1 right now. Let's go ahead and give this a shot. Okay, so question number 1 is pulled up right now. It says that the regional manager of a grocery store is concerned that there may be significant difference between 2 of the stores she is managing regarding the average time it takes employees to check out. So what they're looking at here is the time it takes employees to check out. You can see the averages for store A and the averages for store B. These are just the times from each individual at the store. First things I want you to realize here about this question is what kind of question it is. Since we have store A and store B, we are going to get 2 means for each store. We're going to get a mean for store A and a mean for store B. Without even going any further into this problem, you should realize at this point it is a 2-sample t-test right here, a 2-sample t-test. So it'll obtain a mean for store A and a mean for store B. We scroll down here to the data a little bit further, and I think I have to. You guys can see. You guys can't see anything or anything. Please tell me. She's saying something to everyone. Can I scroll down on this? Yeah, it's a fault of it. So now, what we notice here is the first thing we want to do for this problem. Oh, and it does do that. Okay, I answered my own question. Sorry. It does allow me to scroll down. That works. Awesome. So thanks. Thank you guys for putting up with this, and any feedback you have is going to help. If you guys think this is horrible, I apologize, but I'm learning how to do this as I'm doing it because I've only watched videos on how to do this, and this is my first attempt at doing it. And we're only 10 minutes or so in, and we're on track. I thought it was much longer we'd been doing this for. So looking at this right here with this data, what we have going on right here is we need to first come up with a null and an alternative for this. And what we need to realize is that we need to write it in terms of statistical notation with the mu A and mu B. The most important thing here is to write out statistical notation correctly for this test. So when you do the statistical notation, you need to write, I'm not going to be able to pull up words so quickly on this, I think. Let's go ahead and pull up in Word and have that so I can switch between on your documents. I'm going to switch screens right here and go over to Word. To write the null alternative for this test, we merely do it as, we need to read this as a sentence. The null hypothesis states, and I am sharing the screen now, that the true mean, and the true mean is going to be mu naught. Excuse me, I lied. The true mean for the first sample, mu1, is equal to the true mean for the second sample. That's store A and store B, but it can also be known as sample 1 and sample 2. We're just comparing two means right here. With this in mind right here, the alternative in this question, when you read it, it wants to ask if there's a difference between the two means. The easiest way to write, is there a difference, would be to simply put in the symbol right here, does not equals. So we have, when we read it here, let's change this to alternative hypothesis. The alternative hypothesis states that the true mean for the first store is not equal to the true mean for the second store. And you'd be all right if you put 1 and 2, but we can change that to A and B if we want to be consistent with the question. One quick side note for you is that JUMP actually uses reverse alphabetical order. In JUMP, you will usually see it doing the equations as mu B minus mu A. JUMP does reverse alphabetical order for this. So when you see it in JUMP, you might see males minus females because males come later in the alphabet. So JUMP will do reverse alphabetical order when it tests your means for you. This right here is how we would look at the two means and make nulls and alternatives for their, I'm sorry guys, my screen goes a little bit off at the bottom and I can't see. There's a problem with the projection. Can't see where I was clicking. So with this in mind, this is your null and your alternative. Let's go ahead and switch back to the questions and go back to question number 1. I think this is this one. Do you guys see how I'm just barely off the screen? It's not fair. There we go. So here we go back to question number 1. If you have questions, please ask. Any questions people ask, please ask. Now, when we get to the 4 conditions, there are 4 conditions for a 2-sample t-test. And I just want to see the delay right here. What are the 4 conditions? And start me out and do them in order. Let's see how we're doing on delay on this. What are the 4 conditions for a 2-sample t-test? Remember, it is a 2-sample t-test, so how do we do the conditions? I want to get a little feedback here, see what people are thinking and what people are. So go ahead and respond to me in the chat. We've got 9 people watching. We'll see how this goes. This is my first attempt at this, so I'm sorry if, see how things are going. So the 4 conditions are going to be what? I'm going to go ahead and say them so when the chat comes up, you can check, because I don't want people in chat to be waiting a long time, because I think you guys are just hearing the question now. So the condition number 1 is randomization. We want to randomly select these people. Condition number 2 is 10%. We want for there to be 10%, excuse me, less than 10% of the population sampled. And condition number 3 is the nearly normal condition. The distribution of these means has to be nearly normal. Now let's scroll up for a second and see what they're actually doing here. If you think about it, we can do a test to see if things are nearly normal by doing a Goodnessoffit test. This right here, when you see this, a Goodnessoffit test is actually testing the nearly normal condition. So with this in mind, we test the nearly normal condition for quantitative data. I see a lot of chat right now, and a lot of people are getting a bunch of right conditions, but the biggest thing when it comes to this test is picking the right conditions for the right test. And don't worry, at this point, that would have only been just 1 or 2 points off. But the 4 conditions for a 2-sample T are randomly selected data, less than 10% of the total population is sampled. We have the nearly normal condition met, that the distribution of means are nearly normally distributed. And then on top of that, we need the 2 groups to be independent of each other. So remember, when you have quantitative data with means, we always want the nearly normal condition. Quantitative data, whether it's 1 mean or 2 means. When there's 2 means, we want them to be independent of each other. Let's keep looking. Great job, everyone, interacting and answering. There seems to be like a good minute delay, like 1 minute delay. It's interesting doing a broadcast with a 1 minute delay. It's it's scary. I can't have interaction there immediately. That's not so fun.
Like TV.
Yeah, it's like broadcast. Now I really like this next question right here. This next question below is the T output for the jump for these data. Based on the hypothesis you specified in part 1, what is the p-value for the manager's hypothesis test? Now, this goes back to our null and alternative. So I'm actually have to stop sharing and reshare again. So let me go and reshare what we have right here. So let's screen share this. The important thing we need to look at right here is the alternative is two-sided. This right here tells you the p-value, or which p-value to use. So if we have the does not equal alternative, we have the two-sided p-value. And so when you look at this right here, and let's see it, because in our jump output, you can actually see the two-sided alternative. The two-sided alternative you're seeing in the jump output is the one that has both areas shaded in. So both of these areas shaded in right here is the two-sided alternative. This is very important because if it was a less than alternative, and if you look at this, that would be store B less than store A. This is a big tip right here. Take this less than sign and plug it in right here. That tells you the alternative, mu B less than mu A. So everyone see, you can take the jump output right here with this, what this says right here, and write mu B less than mu A. And that would be this one down here. Mu B greater than mu A would be this one right here. Mu A different than mu B, or does not equal, is this one right here. Just put your mu store B, mu store A, and that is actually writing the null and alternative. Let's look at the jump output and make sure we know exactly what we have going on right here. I'm going to zoom in a little bit more. With this jump output right here, we have a difference of 7.89. This difference of 7.89 is the actual difference of store B minus store A. So store B minus store A would be 7.89. You can make up figurative numbers in your head, imaginary numbers, I can't talk today, because pretend you put in 10 for store B and 2 for store A. I just made those up. But what is 10 minus 2? It's about 8. That's what this equation would solve out to. It would need to be something like 10 minus 2, numbers I'm just making up, to find a difference of 8 about. Now this standard error is the whole equation of square root of s1 squared over n2 squared, s1 squared over n1 squared plus s2 squared over n2. Square root of all that. Might have said that correctly. I hope I did. I'm going to show it to you now so that way you can see it and not hear it. It's on the equation sheet right here. The standard error for that is this bottom portion of the equation. For the test, it is this right here. This is the standard error. That in the jump output you were just seeing before is what that is calculating. So if you ever see it, this is part of your confidence interval and part of your test. Now take a look at the test, because the test says difference, which is the top, over standard error. Remember, we just said this on the bottom, if that would go away. This on the bottom is a standard error. So this is a standard error right here, and this is a difference. So how do we get a test statistic? We divide the difference by the standard error. That's really key here. Dividing a difference by a standard error standardizes this difference. So let's go ahead and look at that on the question and see how this number was obtained. Remember, we're kind of telling how all the jump output is done, so whatever you see on the test, you'll know how to answer. The T ratio right here is literally the difference over the standard error that we just saw in that formula. Difference over standard error is the T ratio. That's what that equation you saw just solved for. The degrees of freedom comes from that wacky formula. So that's why it said DF on there before, because we get some wacky degrees of freedom. The T statistic you're seeing right here, or T ratio it's also called, is literally one standard error. It is this red line. That one is one standard error above 0. Now if you think about that in terms of Z, that is not that big. That's not that big of a difference. So with this in mind right here, what we see right here is something that did not land that far away from the null. The null is that there's no difference. We landed one standard error above, then we shade the area above, we reflect that, and we shade the area below, because it's a does not equal test, and that area shaded under both this light blue and the dark blue is 30%, and that is a p-value that is very big, so we fail to reject the null. So going on here, we said that store B would have the higher number in the average because B minus A has to be positive, so B is bigger. If we use an alpha of 0.10, what is your conclusion regarding the manager's hypothesis test? So when the P is low, we reject the ho. When the P is lower than alpha, we reject the null. This p-value right here is not lower than alpha. This p-value of 0.304 is not lower than alpha, so we fail to reject. What does this mean? Now here's where we go back to, this is the best way to do this in any context. Go back to your null and alternative. So let me go back over to the null and alternative. We'll open this up for questions in a second. So let's go to the null alternative. What does this mean? So let's go ahead and say it. I fail to reject the null. Now a lot of people will leave it at that, but that's not in context. Just say the null then. I fail to reject the null that the true mean for store A is equal to the true mean for store B. Then go ahead and say, I do not have evidence for the alternative that the true mean for store A is different than store B. All you had to say was, I fail to reject the null that the true mean for store A is equal to store B, and I do not have evidence for the alternative that the true mean for store A is different than the true mean for store B. That is always the way to do it in context. Let's go back over here and screen share our test again. I'll open the floor for discussion here in a second. Okay, let's scroll down. This is one of the longer questions on the test. Your answer to part 5 above is not a complete conclusion for the manager's hypothesis test. State the remainder of the conclusion in the context of the problem. So I think I already did that because this right here, now briefly explain why you circled the answer you did. So I'm sorry, I kind of jumped to the next question in what I just answered. The answer would be you fail to reject the null because the p-value is above alpha. And then in context is what I just said. So let me open the floor to questions. I'm going to type here and then did you... Do you guys... So I'm going to go ahead and do another question here. Whatever question you guys want me to do from the practice test. And we can try to get as much of the practice test in this review as we want. I'll talk through the whole thing and I'll explain it all in context. So I'm getting the hang of how to work this, but tell me what question to do. We're probably already, I'm chatting in the thing right now. So whatever question you guys want, just tell me do this question and I will do it. So, what is your number? What question number, everybody? Any question you guys want? Any question? We'll do all things we can. How about number 2? Yes, let's do it. I like number 2 a lot. So we're doing number 2 right now, and you guys will catch up to me in the future in a second. Future's kind of cool. You are screen sharing. Present to everybody. Yes. That's what I wanted to do. I was doing it anyways. Okay. This is interesting. I like it. Okay. Here we go. So this is about a consumer group right here, and what we have is a drug that they are trying to put on the market. So we have a drug that could possibly go on to the market, and our goal, say that about 10 times, is that we will not release a drug if it's unsafe. So the null right here is that, and I think it literally says that, assume that the null is that the new unapproved drug is unsafe. And you think about it, that's kind of the safest thing. So, and it literally says right here, the null, if you read it, the null hypothesis is drug is unsafe. So let's go ahead and write that over here. I'm going to go ahead